In this video, we're going to be looking at the GI tract infections that are caused by those helminths. So it's just a little background about the helminths and these diseases. So there is a lot of diversity among these that are able to infect or parasitize humans. Kind of eosinophilia is the hallmark of that. So an increased amount of those eosinophils in the blood is one of the main ways of identifying it. Neglected tropical infection can be a large burden of disease to the poorest countries, and they receive the least recognition and research as far as funding. Again, not typically a problem within the United States as much as those developing countries. Some of the clinical considerations as far as pathogenesis and virulence, so they have special mouth parts that help them attach and then feed. They also produce enzymes that can kind of dissolve or liquefy as well as move through tissue, and they have a cuticle for protection against our immune defense. Definitive host is the host in which the adult worm reproduces sexually. So there'll be intermediate hosts, which are just kind of hanging out, waiting to get to that definitive. But whenever reproduction can occur, that's the organism called the definitive host. Again, diagnosis is looking for that increased number of eosinophils, as well as the identification of any of the eggs, larvae, or worms. Prevention and treatment, so no vaccines for any of the helminths. So there are anti-helminth drugs. Again, they're specifically targeted, so not antibiotics, not antivirals. These are specifically targeted to the helminths, but as well as preventative as far as proper sewage, avoiding feces, including fertilizers, disinfection of water, washing and cooking vegetables and meats, and then freezing food. So again, not typically a huge problem in the US, but definitely in developing countries. So just looking at a few different ways, kind of the basic life cycle and transmission cycle. So cycle A for the helminths, the main difference here, so the worms kind of mature in the intestine, so they're going to release the eggs into the feces. And then with this one, those eggs are going to be ingested and the worms will mature inside of the intestine. Cycle B is somewhat similar. Again, the eggs are going to be released into the feces. However, the difference here is the development of the larvae from the egg happens outside of the body, and then that is what is then ingested or exposed to the intestinal tract, or the worms instead of the eggs. Then here in cycle C, essentially there's kind of an intermediate host, so to speak. So the eggs are released from humans, they're ingested into another organism where those eggs develop into the mature larvae, the mature worms that infect that muscle, and then that infected muscle is then consumed by humans as a secondary route. And then lastly in the cycle D, so again the eggs are released, the larvae are going to mature outside of the host, they produce a second larva stage, and then that larva stage is what is going to be ingested either directly or indirectly in one of those two routes. All right, our first one looking at here is Enterovirus formicularis, which is one of the pinworms. This is the most common worm disease of children in the temperate zones, which is where we would be at. Again, at life cycle A, where those the eggs are ingested and they mature in the intestines. The hallmark symptom here is a pronounced anal itching that occurs. Infection, though, is not fatal, and a lot of times it is asymptomatic. The trichuria is a whipworm, also with the life cycle A. So humans are the sole host, the only ones they can infect. High incidence in the tropics and subtropics due to poor sanitation. These females, though, just to kind of put it in perspective, lay thousands of eggs a day in the bow. Again, maturation in adult, the worms are going through the life cycle inside the intestine after the eggs are consumed Some of the symptoms here are localized hemorrhaging of the bowel, dysentery, so that bloody stool, muscle loss, and rectal prolapse that can be fatal in children. Then the tapeworm, which is the Diphtherum latum. Again, humans here are the definitive host. So remember, that's where sexual reproduction occurs. There is an intermediate host, though, which is fish. So it's typically transmitted from sushi or sashimi. Also, though, through undercooked or smoked trout, perch, or pike. So again, some type of fish that is the intermediate host. This is common in the Great Lakes, Alaska, and Canada, where a lot of fish is consumed. So some of the symptoms: abdominal discomfort, nausea, and anemia. Looking at the Hymenopsis species, so these are small tapeworms, and this is the most common human tapeworm infection. Has that life cycle B, so it has that intermediate host where the eggs are ingested by another organism. The larvae are hatched, the worms start to mature, and then the infected muscle tissue or tissues are consumed. Two species, the Nana and the diminuta, sorry. So these are the first one, the Nana, so think about nanometers, really small. These are dwarf tapeworms that are only 15 to 40 nanometers long. And then the rat tapeworm, again, also relatively small, so 20 to 60 centimeters as an adult. All right, so then our worms here, so again, the pinworms here, as well as the whipworms, both of them have the life cycle A. Again, transmission is through food, water, or the fecal-oral route. And then hygiene is the best way for preventing these, as well as sanitation. And then there are anti-helminth drugs that can be treated. Again, the pinworm is common in the United States. The whipworm, humans are the only host that are used. Then we look at a couple with life cycle C, so the fish tapeworm, and then the small tapeworms, the Hymenopsis. Wow, struggled with that one. So again, vehicles with the fish tapeworm, of course, fish. They use up vitamin B12. So again, properly cooking meat, not eating raw seafood, that type of thing is very important. And then those hygienic environments are important. Both of these can be treated with those anti-helminths. All right, then looking at a roundworm called Ascarius lumbricoides. So this is a giant intestinal roundworm. This is typically, if you have pets, especially with puppies, this is typically what they're going to have. So the larva and adult stages in humans, the embryonic eggs are expelled in the feces. They penetrate that intestinal wall, enter into the lymphatic and the circulatory system. And then the issues become, they get swept into the heart, and then rob the capillaries of the lungs, so they can migrate into that respiratory tree, and then the worms can actually be swallowed and returned to the small intestine for like a reinfection. All right, so these intestinal distress plus the migratory symptoms, so Toxocaria species, again, they have cycle A, so dog or cat feces is typically where ingestion occurs. Again, proper hygiene. All three of these are treated by the same anti-helminth. Some of the discrete, kind of distinctive features with this one, the migration symptoms actually can lead to blindness. Then the intestinal roundworm, the Ascarius, again, life cycle A. Again, proper hygiene, same treatment here. Most of the time, this is mild or unnoticeable. The hookworms, though, the Necator americanus that causes these hookworms, this has the life cycle B, which is where the eggs are released. They mature outside of a host or out in the environment, and then the worms are actually ingested. Again, proper sanitation is really important with this one, but these can penetrate the skin and cause serious intestinal symptoms. All right, the tapeworm here, Tinea solium. These adult worms can be really long, up to 5 meters. They're distributed worldwide, but concentrated where people are living really close in proximity to pigs and undercooked pork. Again, life cycle C is commonly used here where it has that intermediate host. Again, the pigs would have taken the eggs, the larvae would hatch and become worms, and then we would consume the infected pork that contains the worm. Cysticeriosis occurs in humans ingested with the eggs rather than the infected meat. And just a little information here, again, that's summary. So cycle C, again, prevention is that cooked meat, again, avoiding the pigs. There is an anti-helminth that is available. Kind of the distinctive is those intestinal or ingesting those larvae of the pork is what leads to the intestinal tapeworms. So ingesting the eggs, though, has a different name called cysticeriosis. And then the larval cyst can become embedded in the new host. And it's showing here a picture of the brain that actually contains some of these worms where they have been able to migrate. Obstetricourse, senecio, and then also chlorinocourse senecio. So these are referred to as Chinese liver flukes. They have the cycle D that occurs. So those larvae hatch and crawl into the bile duct, shed the eggs, and then those move into the intestinal tract. This is a slow to develop symptoms, thickening of the bile ducts. Granulomas can form in the liver and can even block those bile ducts. Fascolia hepatica, as the name kind of implies here, we're going into the liver. So this is also a liver fluke. This is common in sheep, cattle, goats, and other mammals. Outbreaks associated with eating wild watercress. Has a complex, kind of unique life cycle where the animals or mammals are the definitive host, where that sexual reproduction occurs. Some of the symptoms, so we have vomiting, diarrhea, hepatomegalia in the liver, bile obstruction from a large number of flukes can also occur. All right, so summarizing our liver and intestinal table here. So we have our obstetricourse and then the chlorinocourse senecio. Those are both hard to say. And then the Fascolia. Both of these have the life cycle D. Again, prevention is through proper sanitation and cooking of food. And then both have anti-helminths that can be useful. But again, both of them, those distinctive, these are liver flukes, so they can live in the liver. And the Fascolia can even live inside the gallbladder. All right, some of the muscle and neurological symptoms of trichinosis. So trichinella can be transmitted by eating pork and some other wildlife. Again, ingesting those cysts that can be formed. It's prevented by adequate storage and also cooking of pork and wild meats. It is maintained, the parasite is maintained cysted in the muscles. So again, those cysts, which is what we're seeing here, so they're essentially enclosed in these compartments within the muscle, and that's what allows them to then be ingested if not properly killed through cooking, through the cooking process. Continuing on here, some of the symptoms can go unnoticeable and then can range up to being life-threatening. So kind of the first phase is that GI, so the diarrhea, nausea, pain, fever, sweating. Then the second phase is it moves, puffiness around the eyes, muscle and joint pain, shortness of breath, and the eosinophilia, so that increased number of eosinophils. So the most effective preventative measure here for trichinosis is, again, adequately storing and cooking pork and wild meats. So the summary table, the trichinella species, again, transmitted by food. So properly cooking that can be treated with an anti-helminth, but also supported with steroids to decrease the inflammation that occurs. The reason it can be fatal is due to the brain and heart involvement that can occur. All right, another liver disease here, schistosomiasis, that is caused by Macedonia in the Japonicum species. So these are both look different and they're in different regions, which is why they're separate species, but they have similar life cycles, transmitted similarly, and look similar. And both of them can invade intact skin. So again, thinking we're not just ingesting them through food, but they can actually kind of burrow or move into or through intact skin. Some of the signs and symptoms, so itchiness in the area where the worm enters the body, again, from like being in contaminated water or in the ocean, they can bury and penetrate through healthy skin. So fever, chills, diarrhea, and cough. In a chronic infection, hepatomegaly can occur, liver disease, and splenomegaly. It can also obstruct the bladder and cause blood to be in the urine. And it can cause granulomatous response, again, granulomas, where the immune system is kind of clustering and trying to target that. And those can occur in the nervous system and the heart. A little bit more information about it. So this parasite coats its outer surface with proteins that look like the bloodstream, so it doesn't look former, so it kind of disguises itself to evade the immune system. It's diagnosed by looking at those eggs. And then the cycle of infection can be broken as long as people are exposed to untreated sewage, because again, these can burrow through intact skin. And again, one of the helminths, anti-helminths, is available for treatment. So our summary table here, just looking at both of these are cycle D, and are going to be transmitted by contaminated water. Again, that antigenic cloaking or kind of disguising itself. So in avoiding those contaminated water sources, as well as treatment that's available. But again, its hallmark is that it can penetrate through the skin, then becomes lodged in the blood vessels, intestine, and even damages the liver. All right, so kind of summarizing, finishing up here with this chapter, just looking through some of the summary tables here at the different organisms. So a lot of bacteria here as far as food poisoning, cavities that are the cause of that. Again, even more bacteria listed here, leading to periodontal disease, again, acute or chronic diarrhea, cholera, ulcers, vibriosis. And then we do have some of the viruses, so particularly the hepatitis, A, B, C, and then E, and E really mimics a lot of the A. But then we also do have the Nora and rotaviruses, as well as the mumps virus, that are part of our GI tract infections. And then some of the protists as well that we talked about, so the Cryptosporidium, Cyclospora giardia, and the Entamoeba that lead to that acute or mainly chronic diarrhea. And then our helminths, so again, whether it's whipworms, tapeworms, the flukes, like liver flukes. So again, all of these are causing intestinal distress. Just also some include that migratory symptoms that can go to other, just meaning they can go to other organs as well. And then just another table here of our helminths, so the cestodes and trematodes that lead to those intestinal distress, cysticeriosis, then liver and intestinal diseases, the schistosomiasis, and then other liver and intestinal diseases that can occur from these helminths.